applied. So over here you have PZ1, PZ2, okay, and then you also have a torsion. Okay, and this shaft, you have to optimize this with, we're going to produce this shaft out of carbon fiber reinforced plastic. And unfortunately, right, the carbon fiber can only withstand axial loading. Okay, so maybe we can have another force applied down here. Okay, px1 prime. Okay, so it's multi-component loaded, right? And we have to do this with carbon fiber. Unfortunately, carbon fiber can only withstand what? Axial loading. Okay, it cannot withstand. So there will be a unique direction. Okay, there will be a unique direction. Okay, to lay the carbon fiber orientation. Okay, so to determine this direction or this orientation, okay, Mohr circle has to be used. Okay, so you see in the video, right? The video I played earlier, they mentioned about software. Okay, yeah, I mean, if you have the luxury of using software, good for you. What if you don't have the luxury of using software? And it's not difficult to calculate. Software like this are not cheap, by the way. Okay, what I'm going to do is for the next 3 hours, okay, which will carry on next week, I'm going to teach you how to determine the orientation. Okay, and this is manufacturing of carbon fiber reinforced plastic. As you can see, why am I teaching you to determine the orientation? Because we as engineers, we will determine the location. Okay, we are not the one mixing the epoxy. Okay, cooking it. No. Okay, we tell them what is the first direction to lay and what are the subsequent direction. Okay, so here we go. So let's go look into Mohr circle. Okay, let's go into Mohr circle. Now, some of you have done Mohr circle before. Some of you have not. Not to worry. Okay, chemical engineers can do Mohr circle very well. Also, okay, I've been teaching this course since 2010 with this topic. Chemical engineers do well with it. Okay, so let's look at the Mohr circle. Before we go into Mohr circle, during your term test or your exam to come, you need to buy a mathematical instrumentation or instrument set. You all know what is this, right? Where you have your compass, your protractor. If you can use your computer to determine the angles, good for you. Okay. If not, you have to use mathematical instruments. Okay.
Hey Eugene, just a quick question. Do you align this with the other courses? Because subsequently we also need mathematical instrument set in 2D03, and we just needed it starting like this week.
No, this is coincidence.
Coincidence?
What you're doing with mathematical set in 2D? Can you tell me more?
For CAMs.
CAMs you design different stuff. Okay. Over there, you design a cam. Over here, you learn how to make the cam by controlling residual stress. Okay. Okay.
Hey, Eugene.
Yes.
Just quick question while we're talking about the midterm. Is it cumulative or is it just?
No point me asking you the same stuff, right? So whatever I teach last week, okay, to the end is what I'm going to test you in the final. I don't believe in like, but you still have to remember what you learned before, okay? Because later on, when I go into method cutting, I'll introduce Johnson-Cook equation again, okay? Does that make sense? Hello?
Yeah, thanks, Eugene.
Okay. So before we go into Mohr circle, we have to look in the rules of the circle. Okay, we have to look at the rules of the circle. So what I want you to do, if you can, okay, I want you to draw a circle. Mine is not a perfect circle, but it's still a circle. Okay, so I will request you all draw a circle. So after drawing a circle, I'm looking for my ruler, and my daughter took my ruler, and I can't find now. It's okay. So if this is the center point of the circle, I'm going to name it O. Okay, we are going to draw a straight line. Okay, we are going to draw a straight line. So you'll do the same. It can be any orientation. Okay, it does not need to be exactly the same as mine. Okay, it can be horizontal. So I'm going to name this point A, and I'm going to name this point B. Okay, and I'm going to pick any point. Okay, so over here I'm going to pick my point C. Okay, so at point C I'm going to draw a straight line. Okay, so this is my point C here now. Okay, that's my point C. And then I'm going to draw a line coming down here this way. Okay, and what you realize is this is 90 degrees. Okay, always. Okay, so if I were to pick another point at the bottom, okay, this is also always what? 90 degrees. You can draw it accurately. You always get 90 degrees. Okay, so after that, I want you to take a point down here. And the point down here, I want you to draw a straight line to join point O to point C. Okay, that is point O to point C. Okay, and if this angle is called alpha, right? This angle is also equal to alpha, right? The angle over here is equal to 2 alpha. Okay, and why is that? Because the angle over here, right, is 180 minus 2 alpha. Okay, so if you were to do Mohr circle, you have to know the rules of the circle first. Okay, so one of the rules of the circle states that if you pick any point on the circumference of the circle, you join point A to point C to point B, you always get what? 90 degrees. Okay, so from point C to the center at O, and when you measure the angle, over here is alpha, over here is alpha. These two angles, this is an isosceles triangle, right? Over here will be what? 2 alpha. Because why is it an isosceles triangle? Because these are its what? Radius. Okay, so this is the rules of the circle. So before we go into Mohr circle, you have to know the rules of the circle. Okay, right. Any questions so far? I think you guys know this from high school. Okay, high school, I think you all learn all this. So as I mentioned, we're going to use Mohr circle to determine the orientation of the carbon fiber. Okay. So before we do that, let's look into what is normal stress. Okay. What do we mean by normal stress? So normal stresses are acting perpendicular to the surface. Okay. So what do I mean by that? If I have a shaft, okay, I have a load, okay, P and P prime, right? And then normal stress is equal to, okay, normal stress. So for this case, if I will draw, this is my transformation, X, Y, and this is our Z. Okay, normal stress in the X direction is equal to P prime divided by A. So some of you might say, Eugene, where's A? So this is A, which define the cross sectional area. Okay. The next thing I'd like to introduce you is what we call an element. Okay, the next thing I'm going to introduce what we call. So let me draw what is an element first. Okay, so an element. Okay, this is my element. So this is my element. It's a square. Okay, this is a square. And if I were to draw my orientation of my element relative to the transformation over there, this is my X and this is my Y. Okay, and then some of you might say, Eugene, where is this element on your shaft? Okay, so the element, okay, and the element is the point of interest or specific location of interest. Okay, so for this case, this is where my element is. Okay, that's my element. I draw curve is because the surface is curved. Okay, but in real life, what is an element? So if an element can be what? So over here, let's say if that is my element, right? What does it actually mean? It's actually strain gauges. So all these are strain gauge. Okay. So when the strain gauges are stretched or compressed or twisted, stretched and compressed, the resistance change. When the resistance change, you measure the voltage. When you constant current, you measure the voltage. You can relate the voltage to stress field. Okay, so that's what I mean by strain gauge and relative to the element. So in axial loading, right? This is our stress X, and this is our stress Y. Okay, that is on the element. Okay, so for this case, you can see that it's normal because it's 90 degrees. It is pulling out, means it's tensile, positive. Okay, positive means it's what? Tensile. Over here is also positive, it's pulling upwards, means it's also what? Tensile. Okay. So we will make the first assumption where stress X is greater than stress Y. Okay. So next thing I'm going to introduce to you is I'm going to introduce to you Mohr circle. Under normal stresses. Okay. So Mohr circle has two axes. The horizontal axis is known as our normal stress, okay?